DNA itself, what it is and how we can utilise it to put our family jigsaws together. DNA stands for deoxyribonucleic acid, and I hope never to have to say that again. In future I'll say it stands for do not ask. It's a molecule that carries genetic instructions for the development, functioning, growth and reproduction of all known organisms. It's DNA that makes us who we are as individuals, DNA that determines how each of us looks, the colour of our eyes, the consistency of our earwax, the shape of our liver, the functionality of our brain and so on. And that is as technical as I'm going to get today. Our interest in DNA from a genealogical point of view lies firstly in the fact that it was passed to us by specific and identifiable ancestors, and secondly that it's possible through DNA profiling to compare the DNA from one individual with another and to identify where there is a family relationship. Everyone has their own unique mix of DNA. No two individuals are precisely the same unless they are identical twins. But we can still share some of our DNA with each other where we share an ancestor. There are different types of DNA tests which examine different things. I'm going to concentrate today on autosomal DNA, which is the main type that is tested by the various different companies. That's what you will be buying on their websites. That's what we use for our purposes. It's the DNA that is passed from ancestors of both sexes to descendants of both sexes. For your interest, the other two types of DNA are Y-DNA, which is passed on virtually unchanged from fathers to sons, and mitochondrial DNA, which is passed on only by a mother to her children. I shall only be addressing myself to autosomal DNA today. We inherit half of our DNA from each parent always. That's how it works at conception. Imagine two people, Tom and Carol. They have two babies together called Joseph and Lucy. And each passes on 50% of their DNA to each child. So the children are made up of 50% DNA from Tom and 50% from Carol. But of course, Tom and Carol's own DNA is actually what they inherited from their own parents in the same way. So now we understand that Joseph and Lucy actually carry around half of Tom's father's and half of Tom's mother's DNA, and then the same again with Carol's mother and father. So roughly a quarter of Joseph's DNA comes from each of his 4 grandparents. And it follows that those grandparents have received their DNA from their own parents. So in truth, the children have actually inherited 1/8 of their DNA from each great-grandparent, and so on. And the next thing to grasp is that the inheritance of 50% of their DNA from each parent is random.